step for 0.1, and the reason it's 0.1 is because this is going to be a quick detour into covering the cube root of unity, which I haven't covered before, so I'll do that right now. And the reason is because we took a cube root right here of the z to the power of 3. So when you take a cube root, you're supposed to get 3 solutions. Here we just got 1. Well, we have a plus or minus inside this quadratic, so that could be a 2. And then you'll have another 3, so that'll be 6. But then this one, doesn't matter which one you pick. So this one, plus or minus, you're going to get basically the inside here as well. So anyways, but nonetheless, we're still going to get 3 solutions for this cube root. Just as taking a square root, you're going to get 2 solutions. For example, square root of 1 is plus or minus 1. And so let's continue further in this. So the cube root gives 3 solutions, just as the square root gives 2 solutions. And we can find these solutions by factoring the square and cube root of unity via the difference of squares and difference of cubes formula, respectively. I'll put this formula respectively. For example, let's take a look at the square root of unity. This is basically w squared. Let's just pick a variable w. Squared equals 1. So now what we'll do now is move the 1 over to the other side. So we're going to get a w squared minus 1 equals to 0. And basically write this as a square. So this is going to be as a difference of squares. So this is going to be the same thing as writing w squared minus 1 squared. And now these links are to my earlier videos on difference of squares and difference of cubes. You get the formulas for them. But for this one, it's just going to be, well, I'll write this actually here. So then what we end up getting is a w squared minus 1 squared. Because 1 squared is just 1. This equals to 0. And now this is going to equal to, before we get further, just expand this out. So difference of squares is going to be w minus 1. So basically you factor this out. It's going to be w minus 1 times by w plus 1. It's similar to the conjugates. So when you have the conjugates, the middle ones cancels out. So similar to this one here. When you have the conjugates, these end up canceling out at the center. Same thing will happen here. So if you expand this out, so w times w, and then negative 1 times w plus 1. So w times w is w squared. W times 1 is plus 1. Yeah, it's just going to be plus 1w. Negative 1 times w is going to be negative w. And then negative 1 times 1 is negative 1. So in other words, these cancel, and you're left with w squared minus 1. So yes, that is correct. Yeah, so what we end up having is just the factors w minus 1, w plus 1 equals to 0. And so then this right here gives 2 solutions. And these could be, when you plug in 1, you get w, you get 1 minus 1 is 0. Or if you plug in negative 1 plus 1 is 0. So you're going to get w is equal to plus 1 and negative 1. So 2 solutions. All right, so now we can do the same thing. So similarly, now we'll have a difference of cubes. Similarly, we're going to have, let's say, the cube root of unity, w cubed equals 1. This should give us 3 solutions. So same thing, let's move it over to the 1 to the other side. So we're going to get a w cubed minus 1 equals to 0. And again, this is the same thing as writing. This is going to be now w cubed minus 1 cubed. Same thing, 1 cubed. So this is difference of cubes. And now the formula for this one, using difference of cubes formula from our earlier video, we're going to get a w minus 1 times it by, so the factors of this is going to be equal to this one, w squared plus w, so w times 1 plus 1, like that. And we can expand this out to confirm. So if you multiply all this out, this is just equals to, multiply this times that, we're going to get a w cubed minus plus w squared. W squared, this one inside here, and then plus w. Now we're going to have a minus, do the same thing. So minus w squared minus w, then minus 1 times 1 is negative 1. So then this cancels with this cancels with this cancels with this, and now we're left with is w cubed minus 1. All right, so then that is what we have. So then what we get is a w, these are the factors, w1, w minus 1, and then w squared plus w plus 1 equals to 0. So now we can solve these. Now we're going to have 3 solutions, and what we end up having is, well, the first one, solutions 1, is going to be this one here, w minus 1. So w equals 1 is the first one. And now the other two is when this one is equal to 0. So this one we get the other solutions. So the other solutions are going to be, and then we're going to have is, so that's solution 1. Solution 2, we're going to have w plus 1 equals 0. This is a quadratic formula. Yeah, it's a quadratic formula using the PQ method. We'll just scroll back up to that quadratic one. So if we have it like this, it's going to be x squared plus px plus q. So now and it's going to be, and then we're going to have basically equals to this right here. X equals negative p divided by 2 plus or minus, and then p squared p squared over 4 minus q. So let's write that down, minus p over 2. And the p is this one here, p is just 1. So we're going to get is using a quadratic formula, w is equal to negative p is going to be, well, 1 over 2, and then plus or minus square root p squared over 4, so it's going to be 1 squared over 4 minus q is 1. Let's go back up here just to get that correct. Yeah, so negative p over 2, and p and q are both 1 in our case, so negative 1 over 2 plus or minus square root 1 squared is 1 over 4 minus 1. So that's what we have. And what we end up having in this case, we're going to actually have complex solutions. So this one here, multiply top and bottom by 4 over 4. We're going to get equals to negative 1 over 2 plus or minus, and then this part right here, negative, yeah, this 1 over 4 minus 4 over 4. So we're going to have a negative, we're going to have a negative 3 over 4. So then this equals 2, I'll just go right over here, negative 1 over 2 plus or minus, then put the negative 1 out like that, times by square root 3, then the square root of 4 is just 2. So then this is just I equals to I. So in other words, we're going to get, that's an imaginary number. So that's to get a square root of negative 1, that's just the imaginary number I. So we have a complex solution. So negative 1 over 2 plus or minus, and then this is going to be, I'll write this as I square root 3 over 2. So this is solutions, this is going to be W. So I'll put solutions 2 and 3 equals this one. I'm going to box this in. Solutions y equals 1 is the first solution. This is the second one. All right, and we could refer to these as, we'll write this as W naught equals to 1, just a trivial one. W naught equals 1, just 1 is, 1 like that. And then we'll write, the next one is going to be W 1. This equals, let's do the plus 1, so negative 1 over 2 plus I square root 3 over 2. And then lastly, we're going to go W2. This equals 2. This one, we'll write this as, negative, take the negative one. So negative, and then this is going to be I square root 3 over 2. All right, so the cube root of unity has 2 complex solutions and 1 real number. Yeah, I'll remove that line right, and I'll box this whole thing out. Those are the solutions there. And now also note that 1 over W1 over this one here just equals to W2. And we can see this by, you could do some polar changes to polar coordinates and so on, but I'll just do this the brute force way. So if we go 1 over W1, and this will be helpful in our when we put everything together in our solution. So 1 over negative 1 over 2 plus, this is the W1, so 1 over the square root 3 over 2. And now what we're going to do is multiply the top and bottom by the conjugate. Yeah, so in other words, we're going to multiply top and bottom by 1 over, negative 1 over 2 minus I over square root 3 over 2. And I'll move this down. All right, so that's what we have there. Divide this by negative 1 over 2 minus I squared 3 over 2. And now we multiply all this out. And to do that, we're going to go again. This is the conjugate one. So again, the conjugate is just difference of, this is difference of squares. So this one right here is the same thing as writing this one here, difference of squares as we did before. All the middle stuff, as this one, all the middle stuff cancels out. All we'll be left with is the first one squared and then subtracted by the next one squared. So in other words, this is going to equal to, so this equals to, we'll put it over here. we'll put the top normally, negative 1 over 2 minus I squared 3 over 2, and then this equals to the first one squared. It's going to be negative 1 over 2 squared. That's just going to be, multiplied by itself. It's 1 over 4, positive, because negative becomes positive. Next one is plus and then minus, so it's going to be a minus. And then it's going to be I squared. And then we're going to have so I squared, negative sign, and then square root 3 times square root 3 is going to be 3. The bottom is going to be 4. And then what's the next thing that we get is this equals to right here. So 1 over 4. This I squared is equal to negative 1. So that's the number. It's because I is equal to square root of negative 1. So square it all, you're going to get I squared is equal to negative 1. So this one here, I squared equals to negative 1. So then this becomes positive, 3 over 4. And yeah, so this becomes, let's put it right here. Now equals to 1 over 4 minus, this is going to be minus 1, so plus 1, and 3 over 4 equals 4 over 4 equals 1. So this equals 1, this just equals the top. So this equals to negative 1 over 2 minus I squared 3 over 2, and that's just this one, that's just this right here. That's equals W2, equals W2. Again, just confirmed it there, like that. And here, quickly, I move it down here, so I put it down like this. So this is, I'll put it like this, 1 over W1 equals to this. So yeah, there it is. We solved it right there. Also, to give more context on this imaginary numbers, here what it does to this, basically to the solution, or basically what it means is, yes, this is a real number. Now the imaginary numbers are basically just a rotation in the complex plane. So note also that these complex factors are just rotations in the complex plane. So that's the thing with complex numbers, it's a point on a plane, whereas the normal number is just a point on a line, and so on. So if we take the first one here, what this means is, if we take, this is the real part, this is linked to my earlier video on showing complex numbers as rotation matrices, which is very, very interesting. So here's the real part, here's the imaginary part, there's a re at the bottom there. And now we're dealing with, let's say the first one, negative 1 over 2 plus I times it by square root 3 over 2. Yeah, so the real part in this one is going to be this negative 1 over 2. So we go negative 1 over 2 on the left side. So this is going to be negative 1 over 2. All right, and then we go up. We're going to go up now plus I, imaginary number part. So we're going to go up square root 3 over 2. So it's going to go up like this, square root 3 over 2. And what we're going to get is a rotation. Yeah, so basically that is what we get. And there is an angle. The angle is going to be from here to there. And let's solve this exact trig ratio for it. So this is a theta angle. Let's call that angle theta. And now this one here using Pythagoras is right angle. Using Pythagoras theorem, we're going to have square root 3 over 2 squared plus, and then negative 1 over 2 squared. This is going to equal to c squared. I'll just put c squared. So that's going to be our hypotenuse there. So this one's going to be equals to square root, this is going to be 3 over 4 plus, the negative becomes plus 1 over 4. In other words, we get, this is going to be 1. Yeah, so 1 equals 1 squared. Yeah, it's equals to 1 equals c squared, c equal to 1. So this is equal to 1, like that. We'll just take the positive side, just the length over there. So there it is what we have. And we'll get to the exact ratio soon, but then now the other angle is going downwards. It's the same thing, negative 1 over 2 is real part. Now we're going to go negative I squared 3 over 2. So it's going to go downwards like this. And this is going to be 1. This is going to be negative square root 3 over 2 for the second solution. And now we're going to have an angle. I'm going to go like this to make it from the positive, so counterclockwise like that. And that's going to be, well, we want to solve it. Well, we can solve this first by using exact trig ratios. So exact trig rate or trigonometric ratios. And we can solve this just by using a triangle. So what we have is, this is a square root 3 over 2. And the other one is 1. So what we'll do is multiply this by 2. So what we'll get is, and just draw that triangle. So what I'm going to do is draw this triangle right here. We'll multiply it out. So this can be square root 3. Instead of 1, we get a 2. Instead of a 1, we get a hypotenuse, we get a 2. Like that. And now the bottom, instead of half, negative 1, but which the positive side, which is multiplied by 2. So this is a 1. And then, so in other words, we can continue this out and draw this over, just mirror this out, just draw a perfect triangle. So isosceles triangle 2, and this is 1, and this is square root 3 height. So in other words, this is an isosceles triangle, all the sides are exactly the same. And in the middle is 1, 1, 2. Yeah, so in other words, these are going to be 60 degrees. 60 degrees, and then this whole one is 60 degrees. This one's 60 degrees. And 60 degrees is just going to be, this is going to be pi over 3. Yeah, so this is going to be equals to pi over 3. Yeah, so that is it. Because when you sum all these up, it's supposed to be 180 degrees, or pi. So that's pi over 3. So theta is equal to pi over 3. So in other words, this angle right here is going to be 180 minus 60, so 120 degrees, or pi minus pi over 3 is going to be 2 pi over 3. And then if you look at it from this angle, this one here, or we're going to have basically 180 plus 60 degrees, or this is going to be 240. So the solution is basically take whatever, so it's basically a rotation in a complex plane by 120 degrees or 240, and you get the solution to the cube root of unity. And this one's going to be, in other words, pi plus pi over 3. And that's going to be, this is going to be pi plus pi over 3. So times by 3 over 3. Yeah, 3 over 3. Like this. It's going to be now, this is going to be equals to 4 pi over 3. Like that. Yeah, so anyways, so that's the angles. Again, just wanted to go over the complex numbers to illustrate it. So basically the solutions are equals to 1, or a rotation of 120 degrees, or 240 degrees about the, in the complex plane.